Here we have one question from the chapter Similar Triangles. As you can see, we are given a figure and it's mentioned that DEFG is a square. So this is a square here. This is a square. Further, this angle is given 90 degree. That is the angle here. This is mentioned as 90 degree. Now, what we need to show that FG square. So FG is this. FG square is equal to BG into FC. Now, this question involves similar triangles and the triangles, it is important to understand the triangles which we are going to consider to prove it similar. I noticed here that we need this side, that is, we need BG. Therefore, we must take this triangle, like this triangle. And it also involves this side FC, therefore, I should take this triangle. Now, we need to prove these two triangles similar. Now, the idea which we are going to apply here, number one, we know that a perpendicular, a square has each angle as 90 degrees. So this angle is 90 degree. That is this. And by property, this also be 90 degrees. Similarly, here this as well as this angle will be 90 degree. So to keep in mind that in particular that this angle will be 90 here and this angle will also be 90. So let's mention this, that the angles we are talking about, the 90 degree are this. So let's write on this as, let's write on this with a symbol that this is 90 here and this is 90 here. Now we are going to prove this triangle similar. What I can see here that if I consider the triangle ABC, say here angle A is 90 degrees. So can I say that angle B plus angle C is equal to 90 degree. I repeat, the triangle we are considering here is triangle ABC. In this triangle ABC, as you know, one angle is 90 degrees. So by angle sum property, the sum of the other two angles will be 90 degree. And I marked it equation 1. Now consider this triangle, that is BGD. Here in this triangle, we can also say that angle B plus angle 1 is equal to 90 degree for the same reason, that is angle sum property. Why so? Because we have one angle, as you can see here, one angle is given 90 degree in this triangle. The triangle mentioned is this. In this triangle, one angle is 90 degree. Therefore, the sum of the other two angles, that is this and this, should be 90 degree. And that's by angle sum property. Right. So, and mark it equation 2. Now, from 1 and 2, what you can conclude here, they're both equal to 90 degree, the sum. So, we can equate the left-hand side, that is angle B plus C should be equal to angle B plus 1. So, angle B plus C is equal to angle B plus angle 1. This is angle 1. Now, I can figure out that here, I can cancel this B and B, and we conclude that angle C is equal to angle 1. Now, in geometry, we don't prove the same thing again. So similarly, we can write this angle E here, or I should haven't mentioned this angle 1, right? This was angle A. And say if I write angle 2 here, this angle B will be equal to angle 2. This angle B should be equal to angle 2, the same way as we proved angle C is equal to angle 1. So once we have proved these two angles equal, now what we can do, we can prove the triangle similar. Let's say I use this space for proving the triangle similar. Now the triangles which I'm considering here in triangle, that is B, D, G, this is G here. And the other triangle is triangle E, that's BDG, right? So that should be ECF. So these are the two triangles considered. And I can write these two information from here, that is angle C is equal to angle 1 and angle B is equal to angle 2, as proved above. Therefore, we can write that triangle, say BDG, say in any order. Now I know that B corresponds to 2. 2 is nothing but E here. So I'll be writing this as E. And it's D here, and D corresponds to 1 and 1 is equal to C. 1 is equal to C. So that's why I'm replacing in order of correspondence as C, and G is 90 degree. On the other side, it's F is 90 degree. That is by A is similarity. So once we have to prove the triangle similar, what we can do next is to write their sides as proportional. So the sides which are going to be proportional, let's say if I take BD here, that is, BD is not used as you can see here. So we can take BG. Now, like if I take BG, this is BG over EF should be equal to, this is DG over CF. Now, if I cross multiply, what do we get here? We get DG, we get DG into EF. Let's cross multiply is what I'm doing. EF is equal to PG into CF. So this we got already, but we haven't got the left-hand side. We need FG square. Now what you can observe here that this is a square given, right? When in a square, all sides are equal. So I can replace, and once again, I should show you what I mean to say here, that I can replace this DG, that is, this is DG, as same as FG, because this is a square where all sides are equal. So if I do the replacement here, that means replacing what we are getting. Here I'm replacing both with FG. So it's going to be FG into FG is equal to BG into CF. Now FG into FG is what? FG square. So that is equal to BG into CF. And we'll say that's how we prove this question.